right, so hello everybody. Welcome to the Power Systems Virtual Showcase. We are the Queen's Hyperloop design team from Queen's University, Kingston, Ontario. I just want to say thanks to all of you for attending this presentation, especially our team members, professors who will be watching this afterwards, and also our teams from across the world. So my name is Kevin. I am one of the co-captains this year in charge of MEC and research development, and I'll pass it off to Rain.
Hi, my name is Rain Wei, and I'm the Power System Team Manager in Queen's Hyperloop Design Team. And I'm also in my 4th year of electrical engineering, specializing in power electronics.
Yes. So for today, we'll begin with a little introduction of what Queen's Hyperloop is, and we'll showcase our power systems, and we'll talk about next steps, talk about timeline, and a final summary followed by a question and answer period. In terms of introduction, we have, so Queen's Hyperloop has 3 different branches, starting from the most standard technical subsystems, which is our actual design engineers who build the pod. And we have an independent research development branch, which is currently working on a full-size track here in Kingston, Ontario, so that we can host internet conferences here or just test our pod. At the same time, we also have a 20-member business logistics team for business cases, for sponsorship, marketing, external affairs, and internal affairs, as well as finances and inventory. So talking about technical subsystems, here's how we actually integrate Hyperloop into our team. So we have split into 3 sections, starting from mechanical systems, which consists of the propulsion, which if you come tomorrow, you go to see our showcase on propulsion, chassis, suspension, levitation, braking, and finally, now we go to electrical subsystems, which include power systems, which is where it's integrated alongside control systems, more software and more control, sensors, and optics. And lastly, we do have an independent and brand new system design team in charge of doing more testing as well as optimization of our design and looking at overall assembly. And then looking at R&D, we have been conducting a lot of infrastructure research in terms of Hyperloop track, economics, and at the same time, we're looking into better physical testing tools, physical testing equipment, and tracks to be built here in Kingston. Beyond that, we also have technical research, which is where our LIM and anything maglev is involved here. This thing also includes materials, where we do material research, and AI/ML camera systems, which we're investigating as we speak. And lastly, we're trying to move towards mining research, which we hope to expand our team further to actually compete in the knowledge boring competition in the future, alongside the Queen's Department of Geological Sciences, Geological Engineering, as well as Robert M. Buchan, Department of Mining. So looking at our business team, this is how we actually integrate with externals and internals. We have logistics where we actually have real people ready to communicate with other teams and or sort of internal communications. At the same time, we have a marketing team, which has been dealing with our website, dealing with the graphic design for our materials to publish, including the slide that you see right now. And we also have a sponsorship team, which so far has been very successful in acquiring a lot of sponsors and have been connecting us with alumni as well. Now, Queen's Hyperloop has 3 main objectives this year, and number 1 obviously is our new pod completion, which we're looking at MVP to be done by around February. At the same time, we're looking to improve reputation, especially regarding outreach to industry, to other teams here present at CHC and beyond. And we're also looking to rebuild our alumni network, and that kind of connects to our third point, which we want to build up a nice team culture. So I feel like these days we're still a design team. We love to have people who enjoy what we do, and this is also part of expanding the knowledge of Hyperloop to the local community and within our university, or maybe to the entirety of Canada. Now, I'm going to pass it off to Rain to actually talk about power systems, which is the actual topic of today's presentation.
So welcome to Power Systems, and today I'm going to talk about our system design strategy and different modules in our system. The power system design is essential to provide efficient power to the motors and other subsystems in the pod. And on the right-hand side of the slide, you can see a simplified diagram of our system design. To reduce the complexity of the system and to simplify the potential future iteration process, we have considered a modular design by splitting the system into equally functional quarters. Each quarter includes the main battery pack, a motor, BSC module, BMS module, and IMD module. And don't worry if you don't understand these terms. I'm going to explain these later in the slide. So to start off, the main battery packs provide power to the 4 motors. The main battery pack is our main source of power for our system. And the battery pack is composed of 26 polymer battery cells. When connected in series, it has a total rating of maximum 109.2 volts and 600 amps at a capacity of 6,000 milliamp hours at 100C rating. Our system also contains a separate set of low voltage battery modules, ratings of 24 volts and 1400 milliamp hours. And these are two power components that require a constant low voltage source. The module contains several DC to DC converters to acquire 12, 5, and 3.3 volts to supply power to components such as the solenoid relay and the control system module. The 500 amps rated solenoid relay, which is located in the center of the system, regulates the power supplied to the motor by controlling the contactors between the main battery packs and the BSC module. These contactors are basically physical switches used to switch on or off the motor power supply connections. Next, we have the BSC modules, and they're also known as the motor speed controllers. And they control the motor speed upon receiving a control signal from the control system module. The team decided to use an open source BSC module design with a high modularity that allows for easy modifications for high power ratings and easy hardware debugging process. The design is based off an H-bridge connection with a phase current rating of 400 amps. And up next, we have the BMS module, also known as the battery management system module. They monitor the battery's condition while charging and discharging. The BMS module consists of a BMS master and a set of BMS slaves. The BMS master monitor and control the BMS slaves, and each BMS slave is assigned to each battery cell, which means there are 26 BMS slaves for 26 battery cells in one battery pack. The team also used an open source design for the BMS module, which again promotes modularity and easy customization. And lastly, the IMD modules, also known as the installation monitoring devices, act as a safety precaution to prevent accidental grounding. It is connected between the main battery pack and ground. When the resistance between the main battery pack and the ground drops below its set resistance threshold, the system will be alerted and the power supply will disconnect. In total, our system contains 4 main battery packs, 4 motors, 1 low voltage battery module, 1 solenoid relay, 4 BSC modules, 1 BMS master, and 4 set of 26 BMS slaves, and 4 IMD modules. And up next, I will go over some of our plans and what we hope to accomplish this year. So as of last year, we have finalized our hardware designs, and our goals this year is to manufacture the hardware and putting together all the components and make sure the integration test is complete. Our first goal is to design a battery enclosure to securely mount the battery cells in the pod and ensure its stability during the run. A draft of our battery enclosure design is shown on the right. Our initial idea is to place the battery cells in a 3D printed plates and stack them together. The enclosure is designed to be modular so that the battery cells can be easily added if the system requires more power in the future. Since the BMS slaves are connected beside the battery cell, and the battery cell temperature will rise while charging, we're considering a water cooling solution that shares the same water cooling system with the motors. And our next goal is to complete manufacturing the BMS and the BSC modules. This also includes modification of the custom BSC boards. Since our team is in the process of selecting a more powerful and cost-effective motor, we will need to modify the voltage ratings of some of our components, such as MOSFETs and capacitors, in our BSC boards. We have already ordered all the PCBs and components required for manufacturing, and the modules will be assembled in-house, which will provide a great learning experience for team members. Once the manufacturing is complete, a test run will be conducted with a quarter of our system to ensure the integration between different modules in the system is successful. If the test run is successful, we will proceed to the layout and mount the system onto the chassis. This process also includes deciding the wire length and gauge for the motor. And these parameters need to be minimized to reduce the resistance and voltage drop across the wires. In summary, our goals this year for power systems is to complete manufacturing designs and conduct a series of tests to ensure the modules and the integration between the hardware is working correctly. And now I'll pass off to Kevin for stretch goals.
Thank you. So the main point of stretch goals on Hyperloop, or as Queen's Hyperloop, is to ensure that we meet our long-term goals in the first amount of time as possible. And these are a few points in terms of what's technical, and more importantly, we're focusing a lot also on our operations, which have been very difficult over COVID-19. So, which is, I believe, the case for many design teams here at Queens at least, and possibly other teams across the world for Hyperloop especially. And talking about the first stretch goal, our maglev research has been fully underway now on the different branch. Before it was in series, and now it's in parallel alongside the Tango systems developing the actual pod. And furthermore, our second stretch goal, as I mentioned before, is the test track. So we're hoping to convert the Kingston Airport into at least the same specifications of track as the University of Waterloo Loop, which we can then conduct testing here in Kingston instead of traveling around to actually do tests. Another thing is we're working on more test support, so physical testing tools and equipment, and love to make this open source or just make it very public so that we can all work on it together. Because I know most team here ideally will want to have much better testing supports or equipment. And lastly, we're looking at membership retainment rate, which is part of our biggest focus this year, is to ensure that our operations are going smoothly as we actually construct the pods. Now, our final position is as below. The biggest thing that we're looking at is competitive pod running at or exceeds our predicted benchmarks. In the past, I believe during the 2019 competition, our pod was unable to run on the track, which is why this year we're really focusing on performance, and we actually perform on the track to pass our safety ratings and being really careful. And now this is our third year of redesigning, so we're hoping to get everything manufactured and completed by February. And we're looking at tiny membership. So now Queen's Hyperloop is almost 120 members, which is almost double the size as previously, and we'll be continuing expanding next year to support the Not a Boring Competition initiative. And we're also looking at more internal external affairs in the sense that we're reconnecting with the alumni, been dealing a lot with our internal members, working alongside our design teams, and hopefully expand this even further over the next few months. Now, speaking of timelines, we have drafted three timelines to show, starting out with the Tango timeline. And this you can see right now we have reached the manufacturing stage, and within the next few months, we're going to begin assembly and finishing up by February, which then will focus on testing, which is led by system design. Afterwards, we'll be going through debriefing period over summer, as well as hopefully competing at the European Hyperloop Week with our research development efforts. So for this, we're hoping to create reports, analyze data, and organize our assets and hopefully make them public. We would love to introduce many teams to what we do consistently and on paper. In terms of R&D, we have cut into three different phases, and right now we're looking at research and structural. So that means looking into the maglev prototyping, and as well as working on mount for the rails, which is a great physical testing tool. And then moving forward, we're looking at what we call choo-choo train, which what it actually means is the toy scale model of maglev. The biggest problem we have encountered right now is that our Tango system is really well established, so we do want to go through with our existing design, but in the future years, we'll be integrating these prototypes directly onto our pod. And afterwards, phase 3 is scaling up from a toy size scale to a smaller but larger than the original scale model. In this case, targets will be locked and published for implementation. And all three timelines really go through the same process of debriefing to make everything published and be public. Now, looking at business timeline, we have been going through recruitment, has done outreach, and just lost sponsorship we've been working at with a very big sponsorship team with support from the Smith School of Business here at Queens. And moving forward, we're looking at a lot of events to hopefully educate the public, not just in Queens, but to the community here at Kingston, and maybe even bigger to the entirety of Canada. And this includes potential conferences, like review events, or possibly sponsorship events, which will help the community here in Canada. Now, as a summary, what Queens has been really focusing over the past few years, and even now has been building a strong foundation for the future. Everything has been standardized. In this case, we became more independent and have been constantly trying to acquire more faculty support and graduate students. With our existing graduate students, we've been getting them on board with our research initiatives, which is part of the team expansion, which is new hires and new subsystems to make sure that our system is ready to, I guess, to face the newer challenges. And now, looking at new innovations, as I mentioned, the biggest problem we suffered in the past has been in series, research being done in series as our technical systems, which means we would do implementation first and then do new research and then implement and then research. Now we want to make it parallel, so we do both at the same time and speed up the innovation process a lot faster. And lastly, we're planning ahead to really look into long-lasting impact within our community through our public events, outreach, and hopefully secure more funding for the future as well through this initiative. Now that sums up our presentation today. If there's any questions and answers, please do ask them. Also, if just any team wants to kind of talk more in detail, I do encourage to send us an email anytime to have more in-depth conversations. But for now, thank you very much for listening, such to our team members, our teams, our sponsors, and our faculty.
Thanks, guys. That was a really cool slideshow. Lots of cool transitions. Does anybody have, oh, looks like we have one. Hey, Rain, could you please shed some light on what kind of IMD you guys use?
Sorry, I can't really go into the details of the specs our team use because we're also in competition. So I cannot answer that. Sorry.
Yeah, but I think if you want to learn more, I think what we should do is please send an email. I think that'd be great. We can definitely talk more that way. Just a lot of details are not really summarized, and there's some details that really involve sponsorship. So I think we can definitely talk more in private.
Is there an email that Vivek can reach you guys at? Do you want to send it in the chat maybe?
Yeah, I'll put in chat right now.
Awesome.